So I'm going over indifference curves, and here we have a map that has two packages. One package has 3 bars of chocolate and 2 bananas. This is one bundle. And the other bundle is 1 bar of chocolate and 4 bananas. And the question is, which does this person prefer? Which of these two packages are they going to choose over the other package? And there's nothing on the map that will actually tell us that yet. And that's what indifference curves do. And the key insight of this video is that you can think about indifference curves as a contour map of utility mountain. So how does that work? So if we have a mountain that looks like this, we can see that the 1 4-point with 1 bar of chocolate and 4 bananas, that's at a higher utility elevation than the 3-2. That tells us this person gets more utility from the bundle that has 1 bar of chocolate and 4 bananas than they do with the bundle that has 3 bars of chocolate and 2 bananas. So maybe this person is a real health nut. They don't want to eat too much chocolate, but they like fruit and bananas. We can see that this point is higher up on utility mountain, meaning the utility level for this indifference curve is going to be higher. This might be utility level of 20, this might be utility level of 15, and this utility level might be 10. And we know that along an indifference curve you have the same amount of utility, so as you move uphill on utility mountain, your utility is going to increase. And we might have a different situation if the person really liked chocolate. So let me draw that right now. So here's an indifference curve map of someone who really likes the 3 bars of chocolate and 2 bananas better than the 1 bar of chocolate and 4 bananas. So we can see that the 3-2 combination is higher up on this person's utility mountain. They might only get 15 utils from the 1-4 package, whereas they get 20 utils from the 3-2 package. Let's think about this by looking at an actual contour map. So here we have a contour map, which is a series of mountains we're looking at from the bird's eye view. And we've got 3 different peaks of mountains in this mountain range that we're thinking about planning a hike around. And in a classic contour map, we have evenly spaced elevations. So here we have 1,000 feet above sea level. Here we have 2,000 feet above sea level, 3,000 feet. So we can see as we move toward the peak of this mountain, we're going up and up and up. And if we had someone on the hike who was kind of scared of walking up elevation too fast, their heart rate gets up too fast, they want to take a slow incline up the mountain, we might think this is the best path for us to approach the top of the mountain, because as we move in this direction, it takes us a really long time to go from 1,000 feet to 2,000 feet. This is the slow walk toward the peak of the mountain. On the other hand, if we have rock climbers or people who really like a vertical elevation, we could take this route up the mountain because we're moving up in elevation pretty fast as we move towards the peak from this direction. And we know that if we're standing, say, on this particular elevation level and we walk around that elevation level, we're neither gaining height nor losing height. This is going to be a pretty easy flat walk if we're simply walking around the mountain along this peak. And that's going to parallel indifference curves. And some other things here are also going to parallel indifference curves. For example, we see that none of these elevation marks cross, and you always hear indifference curves don't generally cross. It's for the same reason. Another thing to think about is that the steepest way up utility mountain, if you're standing right here, is going to be whatever's perpendicular to the indifference curve. So if you're standing here and you want to really fast hike that's going to increase your heart rate a lot, you're going to want to go perpendicular to the elevation level or to the indifference curve. One more point here is that every single point on this map has an elevation. So if someone were standing right here, there's somewhere between an elevation of 2,000 and 3,000 feet. This might be an elevation of 2,500 feet, for example. And we could draw a curve that traced this mountain along the 2,500 foot marks. And you could do that with absolutely any point on the map. Coming back to our indifference curve map, we're back to our chocolate, which is good x1, and our bananas, which are good x2, and we have our 2 points, 3 bars of chocolate and 2 bananas, and 1 bar of chocolate and 4 bananas. And we've mapped this onto an indifference curve map that actually has a satiation point. And a satiation point is just the peak of utility mountain. That means as you get more and more chocolate, you get more and more utility, you're happier and happier until you reach 7 bars of chocolate. And after the 7th bar of chocolate, your stomach starts to hurt a little bit. So you start to go down a utility mountain. You have a lower level of utility if you have 8 bars of chocolate than if you have 7 bars of chocolate. This particular person prefers the 1 bar of chocolate and 4 bananas over the 3 bars of chocolate and 2 bananas because that's higher on their utility mountain. And this is generally how indifference curves work. Now we know that satiation points are somewhat unusual because normally utility mountain goes up and up and up forever, and that's a pretty easy thing to have happen because you know there's the rule of free disposal. If we have more than 7 bars of chocolate, we can just throw the 8th bar in the trash rather than get a stomach ache for eating it. So because of that rule of free disposal, the actual utility mountain that we use in most problems is just going to go up and up forever. So this would be a more classic version of utility mountain, and just like we had before, any particular point on this map has a utility level. So I could close my eyes and pick a random point on the map. I picked this random point, and I know there's some amount of utility associated with this point, so I could always pick the elevation level around utility mountain that matched that point. This might be utility equals 40. This might be utility equals 20. This might be utility equals 10. Finally, we might want to think about what utility mountain looks like from different people's perspectives. For example, if we have Amy standing right here looking at utility mountain, what does she see? And it's actually pretty cool what she sees. As she looks from her right to her left, she's looking along the x-axis. She's looking from 0x1 to 8 or 9x1. That's what she sees as she scans along this axis. And of course, she's seeing the mountain go up and up and up. So she's actually going to see a production function. Let me draw you a picture. I meant a utility function, not a production function. This is what Amy sees. From her right to her left, she sees increasing amounts of chocolate, and the elevation she sees as she looks up into the sky is going to represent utility mountain. This is her view of utility mountain. So we have the utility function is the side view of utility mountain, and the indifference curve map is the bird's eye view of utility mountain. It's a great way of thinking about these concepts. I hope it helps.